Hi everyone, welcome to Linear Model with me, Sarini Abdullah. In this video, we will be doing model diagnostic, especially checking the normality assumption. In previous video, we already learned why we need to do residual analysis. And we also learned that although the model diagnostic is for checking the assumption about the errors, but instead of using the errors, we will be working with the residuals. So then the diagnostic checking is through residual analysis. And for this video, we will be checking the normality assumption for the errors. And one way of doing that is that by plotting the, again, the value of the y cap, that is here the filter regression. This is the y cap and the value of the residuals. And again, what we expect from the residual they should be concentrated around 0 because we want for our model to be accurate, then the error should be 0, right? So then we want the value of the residuals to be concentrated around 0. There is no pattern, and if they are deviate from 0, they can be positive or negative, but then we want them to be between plus minus 2 standard deviation of the residuals. The ways of doing this is that through the normal QQ plot, because that people usually tend to be more subjective when they are doing this scatter plot, when there is saying like we don't expect any trend, and if there's something a little bit like a trend, probably for one person is a clear trend, which means that the assumption is not fulfilled, while for other people, the trend might not really be significant. So we still can consider them as just, random pattern. So it's really subjective through the plot, like the scatter plot in here that we have in here. So the problem is the subjective, the assessment. So then a more objective one is that through the normal QQ plot, that is by plotting the theoretical quantiles. That is, if we assume that the residuals are from the normal distribution, then these should be the values over here. And this one is that the values of the residuals from the, from our sample. So if the normality assumption is fulfilled in our data, then we will expect that these points here should lie on the straight line here. So then deviations of the points from the straight line indicates like lacking or violation of the normality assumption. Another way of doing or of checking the normality assumption is that the most obvious one is that by plotting the histogram of the residuals. So again, we have our data actual value of yi, and then we have our predicted value of the yi, and then so we can calculate the residual, that is yi minus yi cap, and then because we have the assumption that the error are normally distributed and the error is approximated by the residual, so then it's just reasonable to expect that the histogram of the residual will resemble a normal distribution. So we expect that the histogram would be symmetric, concentrated around 0, and then when the values deviate from 0, then the frequency becomes smaller and smaller and smaller. This is example of the histogram of residuals from the simulation that I did. It's not a perfect bell-shaped histogram, but I mean that when we are dealing with real data, even close enough to the symmetry is already satisfactory to say that the normality assumption is fulfilled. Or other way than the other way of checking the normality assumption is that in addition of the histogram, we can also just ask to plot the density of the residual. So this is the one that we have here is the plot of the residuals that we have in the histogram on the left. And again, if you look at the plot, it's not kind of like perfectly bell-shaped, but again, what do we expect when we are dealing with real data? I mean that here we can see, oh, okay, the value around is concentrated around 0, and then is unimodal, and then when it goes away from 0, and then the frequency becomes, smaller and smaller and smaller. So that's good enough to say that the normality assumption is fulfilled. While if we have kind of like one on the right side here, this is a perfect one. It would be very nice if we can have something like this, but that slightly different from this, this pattern is still acceptable for the normality assumption. So, sum up again, we expect that residual plots should have no patterns and should be randomly scattered between plus minus 2 standard deviation of the residual. It will show a good fit of the model. And then for the normality assumption, we can use QQ plot, histogram, or density plot as a visual tools for checking whether this assumption is fulfilled or not by the data.